Okay, Louise, this is for you. So here we go. All right, so what we started talking about yesterday, we'll continue today, and we got a lab tomorrow on it. We got another lab on Thursday about this. And it's how you represent information on three different graphs: position time graphs, velocity time graphs, and acceleration time graphs. The position and velocity graphs are your bread and butter, okay? We'll talk about acceleration graphs, but those spin out of what happens with the velocity and the position time. So let's talk about something simple. So if I take the dude, and in this program, they made 0 the reference point, and anything to the right is positive, anything to the left is negative. That is not set in stone, okay? That is not a cardinal rule that says, oh, anything to the right has to be positive. Okay, typically it is, because that's how you see it on a number line, okay? But again, there's a couple of things I want to get out of your minds right now. One is the idea that positive velocity always means that you go away from the reference point, and negative velocity means that you come back to the reference point. Get that out of your minds right now. Get out of your minds the idea that positive velocity means you're going forward and negative velocity means that you're going backwards. Again, get that out of your minds. Don't, okay? And most importantly, get out of your minds that positive acceleration means that you speed up and negative acceleration means that you slow down, okay? Does it happen that way? Yes. Is it one of the golden rules? No, okay? You can speed up with negative acceleration. You can slow down with positive acceleration. So again, and also most importantly, when I say, hey, something's accelerating, get out of your minds right now the idea that, oh, that means that it's speeding up. In a physics classroom, acceleration just means you're doing one of three things. You're either making velocity vectors bigger, you're making velocity vectors smaller, or you're changing the direction of the velocity vectors, okay? The word decelerate has no meaning in this class. So if I say, hey, the squirrel is going to accelerate, you need to get more specific, like, hey, Burkamp, what's the squirrel doing? Is the squirrel going faster? Is the squirrel going slower? Is the squirrel running around the tree? What's it doing, okay? Because that's a difference in terms of how we define these things. So I'm going to do something simple. I'm just going to take the dude, and I'm going to make you move away, and then I'm going to make you move back. Oh, hold on. Okay, so let's talk about this, how this plays out. Let's start with the position time graph. Very, very complex movement can be broken down into simple ideas. So start with this idea. Did the dude change direction? Gavin. Yes. So as soon as you see something change direction, what do you know has to happen to the sign of the velocity?
Has to go negative at one point.
No, bad.
Okay, my fault.
Bad. You're about halfway there. It doesn't have to go negative, but it does have to, it rhymes with change sign.
Change sign.
Yeah, it has to change sign. It might go from negative to positive, it might go from positive to negative, okay?
So I was halfway there.
Huh?
I was halfway there.
That's why I said you were halfway there.
Yeah.
Wow, I wish I would have said that. That's on me, my bad.
You're good.
Okay, so it doesn't have to go negative, it doesn't have to go positive, it just has to change sign. Now, in this situation, look at that position time graph. Now, for those of you that are math nerds, which are a lot of you, what do you call it when a graph hits a peak and then comes back down? Relative maximum. If you've never heard that word, don't flip out. Relative maximum or relative minimum just means it's either at the bottom of like the roller coaster or it's at the top of the roller coaster. So on a position time graph, one of the things you'll see is that if you're going to change direction, you have to have a relative maximum or a relative minimum. Fancy term for saying you have to have a valley or you have to have a hill, okay? That's what you have to have. Because there's three criteria that have to be met for you to change direction. Dylan, what are the three, you're driving down the road and you left your mower back at another job site. You're going to back up. So what are the three things you're going to do to change direction?
Slow down,
slow down,
stop, speed up.
speed back up. Those are the three criteria that have to be met for something to change direction. Now, again, don't get hung up on, well, what about circles? We are not dealing with circles. We'll deal with circles later. That's a whole nother ballgame. All we're dealing with is motion in one direction. So, if you look at this graph, this is what's happening. So if you look at that position time graph, notice that we started slow because of the fact that it's a little bit shallow there at the beginning. And then the position time graph kind of has a constant velocity, and then it's going to break over. So at this point, where you have that relative maximum, there's a couple of things that are important. Number one, that's where you're going to have that relative maximum. That's where you're going to show a change in sign from positive to negative. Also, and this is important mathematically, if you go up there and you imagine that's a circle and you draw a tangent line up there at the top, okay, and you only draw tangent lines under very certain circumstances. Number one, you only draw them on position time graphs. You only draw tangent lines when the velocity is changing because that implies that it's a curved line. And what that gives you is your instantaneous velocity. So if I wanted to know what the velocity was, and that's at about that 1 second mark, I could come in here and I could draw a tangent line. Well, up at that top, the slope of that tangent line is 0. Hello.
Good morning. Is this one of your
It
physics
is.
classes that we're enrolling?
Yes, so, yeah, WSU, if you're thinking about taking this to WSU, I was like, oh, it's Tuesday, yes. So, WSU, hear the spiel, do you need access to this?
I think I can connect.
Okay. Do I need to disconnect mine?
See. Maybe. Oh, there it is.
That's right.
Oh, I think you'll have to hit accept.
No.
Okay.
There we go. Love technology.
It's totally optional if you guys are wanting to sign up, but if you do, we're gonna go ahead and go to this website. Did you already give them the spiel on how it doesn't transfer into, okay.
Yep. Yeah, engineering won't count, everything else it does.
What?
Engineering, you have to have the calculus base physics.
Oh, yeah, you did say that.
I did tell you that.
Okay, and then you'll click high school student. If you have taken a class with us before, then you can go ahead and try to log in. Otherwise you'll hit start new application. You guys all, it's gonna be super easy if you guys all have logged in before. Yeah, okay, so, you'll click enroll in classes. And then the student agreement might appear. That's just saying, you know, you get a high school and a college grade. You aren't gonna do anything that's gonna get yourself in trouble, like same rules that apply here at the high school, apply at the college. And then you know that you're signing up for a class at cost, so you're gonna be responsible for that payment. So then you'll click fall 2025 and then you'll sign. Okay, and then the easiest way to find the class is if you guys go to search for classes at the top here in the middle. You change spring to say fall, and then the numbers that you're gonna enter are 1, 2, 5, 3, 5.
Here, I'll write that down. 1, 2, what?
1, 2, 5, 3, 5. And then you just make sure that in the bottom right corner, it says that it's the first block. Cause there's gonna be more than one option if you guys look at classes in the high school. Okay, and then you'll select the class and then hit apply for selected, and you should get the green check mark. The next thing that we're gonna go to is the parental consent form on the left side in the yellow. So this is just sending an email to your parent or guardian. So even if you're not 18 yet, like you have to get signature from them, just saying that they're gonna be responsible for the payment, because if it's not paid, you guys can't go to collections. So somebody has to be responsible for that. Not saying that it will, but if it does. So you can hence send parent consent, and then make sure that you have a conversation with them later tonight, because like when that $199 is due for this class, that's not something that they're gonna wanna know like the day of. So making sure that you tell them beforehand.
And $199 is a bargain.
Yes, it's a lot cheaper.
Like
A lot
that's what
cheaper.
it's something, I just paid $1,200 for a 3-hour graduate class. through
That's
Baylor.
crazy.
Yeah.
Yeah,
So $200 for a 5-hour class, I just paid $1,200 for a 3-hour class.
yeah. I mean, even a 3 credit hour class after you guys graduate high school at WSUTech is $400. So 5 credit hours, I wanna say is like $700-800 with us. But if you go somewhere like Wichita State, K-State, KU, like any of the 4 years, it's gonna be even more expensive there too. And then the FERPA consent form, if you have the blue bar on this, then you've already completed it, you don't have to do it again. If you have not completed it, this is just you giving somebody else access to your educational records. So similar to HIPAA at the doctor's office, like we can't share any of your healthcare records. Same things apply at the college level. Even if you're not 18, I can't share any information unless you say it's okay. So you definitely want to make sure that this is filled out if somebody's going to help you pay for the class. Otherwise, our business office can't take their money. So you can put 2 people on there. You want to put their first and their last name. And then you'll mark what they have access to. So business office, registrar's office is if they want to contact me like as your advisor with any questions like enrollment or if you need help with a transcript. And then financial aid, even if you're not going to WSUTech after high school, we can still help you with financial aid. And then it has you create a code. So that code is 2 letters and 3 numbers, but anything that you want it to be. And whenever they call me, I'm going to use that code to verify that it's actually them. And then the last thing I need in the supporting documents tab is you'll have to upload a copy of your transcripts, because I have to see your Algebra 2 grades or your ACT scores to make sure that you're eligible by the state requirements to enroll into the class. So if I look at your Algebra 2 grades, when you're looking for an A or a B and a 3.25 GPA. If I look at your ACT scores, I'm looking for a 22 on the math portion. If you have neither of those, and we can do placement testing, we just need to make sure that you get that pretty quick, because the deadline is gonna be, let's see.
Should they print out their transcript and scan it, and upload it as a PDF, or what's easiest, Dave?
Yeah, or, I don't know if your counselor can send it to you. Not your, not like the grade report, it has to be the full, transcript.
Like the official transcript?
Yep. Okay, so some other things, when we're looking at grades, so like I said, it goes on your high school and your college transcript. D's no longer get degrees in college, so making sure that you have a C or higher, because that can affect like your financial aid, scholarship opportunities later on. Cause they're gonna look at the GPA, both on the college side and the high school GPA. If you guys wanna write down, or if you can take a picture of these dates, the last day to enroll is September 8th. So you guys added the class today, but I need the transcript and I need the parent consent form completed by September 8th. The transcript is usually the reason that people in this class don't get enrolled, because I don't see one uploaded. But we'll send you guys an email invoice. That's gonna be your instructions for how to pay. So just making sure that you're not trying to pay before you get that, just because it might take us a couple weeks to actually get you guys enrolled. And then we'll also deliver that email with the instructions. We'll deliver a paper copy too. And then the payment is due on September 29th. But you don't have to pay all at once. If you guys want to do a payment plan, it's going to be that right column. So you have to do $30 down, and you have to put part of the $199 down. I want to say it's 25%. But then you can pay the remaining balance over the next couple of months. Okay, if you guys do have any advising questions, I would be your advisor. So I'm here in the building, in the MCA office on the first Monday of every month, or I'm at May South the third Monday of every month. So even if I'm at May South, like, I can pop over if you guys do ever have questions.
And they are amazing to work with. Just email them. Do not ask me any questions. It's magic, okay? Email Megan.
Yes. And then Tyler would be the recruiter that you guys would be working with. So if you want to see how this class transfers, or if you want to do a tour, anything like that, Tyler would be your go-to. Community navigators. So this team, they work out in the community in Wichita, so they're housed a couple different places. So if you guys ever want to partner with somebody, or just like make connections around Wichita, like if you're looking for somewhere to shadow maybe, they might be a go-to, as they work with a lot of different people, and they might like hear something from somebody else of they're looking for like job opportunities for high school students or something. Terry Shippen, she works with military affiliated students, so if you are using like VA benefits, or like the GI Bill, after you turn 18 or graduate high school, she can help with that as well. Okay, so your responsibilities, so paying for the class is the first thing. Second thing, if you decide that you want to drop the class, we have to do that before September 8th. And that's emailing us. So if you tell...
Do not tell me.
Yep. If you tell him, he won't be able to drop you on his side. We have to manually go in and drop the class for you on your account. So you just email us. Make sure that you include your name and your high school so that we know who we're talking to. The signing up before the deadline, that's just making sure that we have everything squared away, like your transcript, your parent consent form. And then if you decide that you do want to transfer this class to another college in the future, you just have to pay for that transcript, but I would wait until you graduate high school, just because it is like $10, $15 every time you send a copy of that transcript. Okay, and then this is our email, if you guys do have any questions, but it's also at the very bottom of your Jumpstart account, in bold. And then I'll go ahead and give you guys one of these. You guys can skip the instructions for the most part because you already did everything, but it has a little bit more information, like on the back page, if you guys do have questions. You guys have any questions for me while I'm here?
If you have any questions, talk to Megan.
Yes.
Amazing.
I'll be in the MCA office all day if you guys do have questions.
And I've got, third block, I have a lunch, so about 11:45.
Okay, sweet, I was gonna ask. Thank you.
Okay, thank you. Okay, now let's get back to physics. Okay, so back to our continuing story. So you have to understand that all of the graphs have to show the same thing happening at the same time. So that position time graph, when that breaks up over center, this is where this is slowing down because that slope is becoming more shallow, like your tangent lines would become more shallow. Then at the very top, at that relative maximum, if you're a math nerd, that's going to have a slope of 0, and then the velocity is going to go negative. So, and remember this for the lab tomorrow. Both graphs have to show the same thing happening at the same time. So when this graph crosses 0, you notice that's when your velocity, at that exact same time, that's when your velocity time graph has to cross through 0. So Dylan said, hey, there's 3 things that have to happen for you to change direction. And that's what's shown on this velocity time graph. So here, your velocity time graph initially has a positive slope. Because remember, and there's no exceptions to this rule. If you're speeding up, velocity and acceleration have the same sign. If you're slowing down, velocity and acceleration have opposite signs. Notice I didn't say, oh, acceleration has to be positive or acceleration has to be negative. They just have to have the same signs. So here, you're starting at 0. This has a positive slope, so you have positive acceleration, you have positive velocity, you're speeding up. Then, now this changes sign, and now I've got negative acceleration, but notice I still have positive velocity. So here's what's important. Just because the slope of your, just because the sign of your acceleration changes sign, doesn't mean that you change direction. So I went from positive acceleration here to negative acceleration, but I didn't change direction because my velocity didn't go through 0. So that happens all the time. You're driving down the road. You switch between your gas pedal and your brake all the time. You go from positive acceleration to negative acceleration, positive to negative. But you don't change the direction every time that happens, okay? You're only going to change the direction if your velocity goes to 0. So just because the slope of the velocity time graph changes sign doesn't mean that you change direction. You only change direction when that line crosses through 0. Now, in this situation, this is exactly what Dylan said. Hey, I got to slow down, stop, and I got to speed back up. That's what's happening here. Your velocity is approaching 0. You have negative acceleration, positive velocity. You're slowing down. You cross 0. Now you have negative velocity and negative acceleration, and now you're speeding up. So this is what's happening. You're slowing down, stop, you're speeding back up. Now, what's happening here is that this is a velocity time graph. I did not change direction at that bottom because all that happened is that my acceleration changed sign. I went from negative acceleration to positive acceleration, but now I'm starting to speed up or slow down depending upon what's going to happen. So a lot of times what I'm going to ask you to do on a velocity time graph, and this is what's going to happen on the assignment today. I'm going to give you a velocity time graph, and I'm going to ask you to draw arrows that indicate if something is speeding up or slowing down. So in this region, you're speeding up. So you would put an up arrow. Cool, I'm speeding up. I'm going away from 0 meters per second. Here I'm slowing down. I'm approaching 0 meters per second. But a common mistake that happens is that you go, oh, I'm still slowing down in this region. No, you're not. You are speeding up because you've crossed through 0 meters per second. Are you slowing down here? Absolutely. But once you cross 0, then you actually begin to speed up. Okay, so here's the next leap of faith that you got to take. So you all, up to this point in your lives, when you've talked about area, and this is going to be relative to some questions on your assignment. Let's say that you have a velocity time graph, and let's say that's 5 meters per second, and let's say that is 4 seconds. Okay. So here's the leap of faith that you have to take. Up to this point in time, whenever you found area of something, it's been something squared. Meters squared, inches squared, yards squared, something, meters, whatever, okay? It's always been something squared. Because the dimensions of rectangle have always been meters by meters, inches by inches, something like that, okay? Now, the leap of faith that we need to take is that this is going to be a rectangle, but it's going to have dimensions. And it's going to have a dimension of a height of 5 meters per second and a base of 4 seconds. Oh, that's kind of weird, but not really. So the area is going to be 5 meters per second times 4 seconds. Oh, the seconds cancel out. I'm going to get 20 meters. Ah, cool. Now that's unnerving because you're going, whoa, whoa, whoa. Area has to be in something squared. No, it doesn't. This is a rectangle. I'm just telling you the dimensions of this rectangle are 5 meters per second by 4 seconds. Those are just the dimensions. That's it. Okay? And that area is going to be 20 meters. Now, in the old school way of thinking about this, you would say, and you all have used this equation before, okay, that distance traveled equals velocity times time. Okay, you all have done this before. Dylan's going to go out, and Dylan's going to run 5 meters per second for 4 seconds. And we multiply that together, and you're going to get 20 meters. So that's the old school way of doing this. Oh, okay, right. 5 meters per second for 4 seconds, he's going to run 20 meters. Okay, you all have done countless calculations with this before. Okay, it's a simple concept. So here's what I want you to see, is that the area on a velocity time graph between 0 and the line represents displacement, which is the same thing as just finding velocity times time. And it doesn't have to be like a nice rectangle. When the lab tomorrow, you can see it can be a rectangle, it can be a triangle, it can be anything. Now, the other way that you can do this problem, I say, hey, Dylan ran 5 meters per second for 4 seconds, how far did he go? So one option is that you can look at it as a geometry problem. And you can draw a horizontal line and you can find the areas like, oh, Brookcamp, I was president of the area club in high school. Cool, you can work it as an area problem. Nice. You like distance equals velocity times time. You can work it that way. Multiply velocity by time, there you go. The other thing that you can do is like if you like ratios. Okay, I told you that Dylan ran 5 meters per second. So that means that he runs 5 meters in 1 second. Okay, you can set this up as a ratio. And we can go, okay, if he runs 5 meters for 1 second, he's going to move X number of meters over 4 seconds. Okay, you can set this up as a ratio. 5 meters per 1 second is going to equal X number of meters over 1 second. Oh, you've done this before. You cross multiply. So 5 meters times 4 seconds equals 1 second times X number of meters. Oh, we'll divide both sides by 1 second. The seconds cancel out. I get 20 meters. So when you have a simple equation where you have distance equals velocity times time, there's one huge caveat, and listen to me very carefully. If you want to use distance equals velocity times time, it's a great equation. It's wonderful, but it's a one-trick pony. It's a good trick, but it's a one-trick pony. You can only, listen to me, you can only use distance equals velocity times time when you have constant velocity. If it's speeding up or slowing down, you can't use that. If you have any accelerated motion at all, you cannot use distance equals velocity times time, okay? You can't do it. You can only use it if you have constant velocity. Okay, so, okay, then stop that for a second. So, we're going to have